Yeah! We're live, everyone. Way to go, Tyler. Raise your hand, rejoicing. We're live. We're live. Here we go. Example 5. For each angle, what? Is that phi, phi, pho, or phum? Phi, phi, that's phi. For each angle phi, find the angle, theta, the coterminal angle with phi, such that it lives between 0 and 360. So this is what we just did on the quiz. But we're calling the coterminal angle, instead of theta subscript coterminal, we're specifically labeling it as theta. It is another angle, after all. All right, so how are we going to do that? That's a huge negative angle. We can do one of two things, right? We can type in negative 28,549, and we can keep adding 360 repeatedly until we get one between 0 and 360, or we can do it the more efficient way, which is to do what? Divided by 360, and that gives us the number of full rotations. 79 full rotations in the negative direction. To get rid of the integer, we do what? You add 79. You want to let the calculator store the decimals. And then you get back down to a negative fraction of a rotation. So then you just remultiply by the exact same number you divided by, and you get negative 109. Now, negative 109, I'm going to go ahead and write it right here, is in fact a coterminal angle with negative 28,549, indubitably. But what did the question ask us? It asks us for the positive angle that's within one positive rotation. Very good. If you have a negative angle, there's always one additional step to do. You just simply add 360, add one more rotation, okay, and you'll have it. So then plus 360, you get 251. And that's the answer we're looking for. So 251. Am I done? 251? Nope. The grubble. Yeah, degrees. Is that degrees Fahrenheit or Celsius? It's just degrees. Which I make a note on their narration of the free response. If you just put degrees on your free response, you didn't get the unit point, because degrees themselves are not the unit, right? It's degrees F, capital F, or Fahrenheit. Yeah. So you need both of those. Yes. Can you explain? I understand how to find the answer. I don't understand why you add the 360. Okay, here it is in slow motion, and I appreciate you asking, because I am doing stoichiometry, but without showing it, it feels kind of sleight of hand. That's degrees if we multiply by one rotation over 360 degrees. That's called a conversion factor, right? It's equivalent to 1. You can multiply by one rotation over 360 degrees or 360 degrees over one rotation. But in the interest of getting the grubble to divide out, the degrees need to be in the denominator. And so when we did that, that's where we got negative 79 point blah, 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 blah rotations. Yes? Then I added back the full rotations, because full rotations don't really matter to me, because that just gets us right back to our starting point. I want to know then, when I ultimately stop, without going all the way around, where do I land? So if you add back to 79, you get negative 0 point blah, 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 whatever it was, 302. And the units on that are now rotations. So let's come back over here and go negative 0.30277, blah, 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 rotations, divided by 1. And I want to convert it back now to what? Degrees. So stoichiometrically, which is a great adverb, by the way, stoichiometrically. Try to use it in your conversation today. One rotation is 360 degrees. So again, we're using the exact same conversion factor. We're just flipping it now because we need to, in order for the units, rotations, to divide out. And when we multiply by 360, of course, we got negative 109, and the units now are degrees. Okay, so that's why it works. And then negative 109, of course, is coterminal, but the question asks us to find the positive one between 0 and 360, so we just add one more rotation to it. And remember, that works because we said to get any coterminal angle, you just keep adding full multiples of 360. All right? Now, that's one way to do it. That's what I would recommend. But again, if you have time and you're bored, you can just keep saying plus 360, and then enter, enter, enter until you get to that first angle that's between 0 and 360. Now, on the test, I'll probably make the angle uncomfortably large so that if you did it that way, you'd squander your time. doing that. But at least you get one right. Yes. Yes. No. I don't really, I mean, if you want to show this, this is great, but you don't have to show that. Right. I would be happy if you just knew how to do that and just showed 251. Now, there are times where I am going to expect to see the stoichiometric conversions, but that's coming up later when we study angular velocity and stuff like that. And right now, since we just demonstrated on the quiz, well, maybe hopefully we demonstrated on the quiz, that we could do that when converting from DMS and back. We don't have to show those conversions anymore either. We can just let the calculator do it for us. All right, so here's what I'm talking about, an uncomfortably large angle. Phi is equal to 4, 5, 6, 7, 8, 9, 10. Yay. That's a big angle, but it's positive at least, right? So what are we going to show? Well, we're just going to go ahead and jump right to our final answer is what we're going to show. So type it in carefully, 4, 5, 6, 7, 8, 9, 1, 0, or 10. Divided by what? 360. That's, whoa, 126,000 full rotations. More than that, actually. So if you were going to be doing minus 360, you would hit the enter button that many times, okay? We want to subtract out the full rotation. So minus 1, 2, 6, 8, 8, 5. And watch this. The decimals are 0.8611. You do not just want to go to the next line and type in 0.8611. Because look what happens when you subtract out the full rotations. You get more ones appearing because the calculator is storing that decimal. So now we just turn around and we remultiply by the exact same number we divided by, which is 360, and we get 309.999999999. Now, here's where you can still get the wrong answer if you write that down. The angle is so big, your calculator is having overflow problems, right? Its cup overfloweth, all right? It's a happy, grateful calculator. Is it possible, then, that you can start with an angle that is an integer, that is no decimals, and end up with another angle that lands at the exact same spot in the coordinate plane that has decimals? No, because we know that these should be multiples of 360 from each other, right? And 360 itself is a what type of number? An integer, right? So if you add multiples of integer to a number or subtract multiples of integers from a number, you should end up with another what type of number? An integer. So your calculator is trying to give you a hint that it thinks the actual answer is what? 310. So this would be one of those times where if you truncate absolutely without thinking, you're going to get it wrong, okay? You should always be thinking, always. That's the whole purpose of really mathematical studies. So is that right? No, I'm not thinking. The answer is what? 310. Yeah. 310. Now, if you want, you could verify that. Let's take 310 and say plus, how many full rotations was it? 1, 2, 6, 8, 8, 5 times 360. Take your angle and add 126,885 full rotations to it. And what should you get? 4, 5, 6, 7, 8, 9, 10. There you go. So now you can check.
So when do we want to look up for this? Only when it's some type of problem where they ask you to find an angle within a certain range?
Yes. Always, actually. Yeah. Always question your calculator. It's a tool, but it's not the boss. You're the boss, okay? And again, that's another reason why I'll probably give you a huge, large, uncomfortable angle, so that you do have that extra burden, I should say, the onus of having to think about what's reasonable. All right. Sweet. Any questions on number 5? Yes, Tyler. You have 2 questions. What's your left-handed question? Can you stretch? Okay. And your right-handed question? Oh, wow. Double stretch. Yes. All right. So let's go ahead and come up with a very important definition. This one is probably more important than a coterminal angle. It's my favorite definition on the entire section. How about that? A reference angle, which we call theta subscript ref for ref. A reference angle. What's the key word in reference? Hence? Rents. Rens priebus? Refer. Refer. Yeah, refer. Refer. What does it mean to refer to something? To go back to it? To allude to it? To point to it? Right? Yeah. A reference angle is a positive acute angle. Time out. Can a reference angle be negative? No. No, it has to be what type? Positive acute. True or false? A reference angle could be obtuse. No. False. False. No. It has to be what type? Positive and acute. So acute means what? Smaller than 90 degrees. Okay? It has to be less than 90 degrees. And positive means it has to be upbeat and greater than 0. Okay? All angles greater than 0 are upbeat by nature. All right, so you can't have a reference angle that's negative, can you? Good. That measures the angle betwixt or between the terminal ray and the closest x-axis. What does that mean? I don't know. It's the positive acute angle that measures the distance or the angle between the terminal ray and the closest x-axis. I'm going to go ahead and draw 4 scenarios right here. Let's find a little spot right here at the very top of the page. I'm going to draw 4 coordinate planes, snap them vertically, snap it horizontally, and then we'll copy. All right, so there are 4 scenarios if your terminal ray lands in the open field, okay? If this is your angle theta, your theta terminates in quadrant 1, what would the reference angle be? Well, it would be the measure between the terminal ray and the closest x-axis. So the reference angle would be this right here in red. So in this case, the reference angle is going to actually equal what? As you mentioned, Rebecca, the angle itself. If your angle is already a positive acute angle that terminates in quadrant 1, the reference angle and the angle itself are one and the same, okay? But we don't always have angles terminating in quadrant 1. What's another quadrant in which our angle can terminate? Quadrant 2, yeah. So let's say we have an angle that terminates right here in quadrant 2. This is your angle theta. It rotates you past 90 and gets you into quadrant 2. But the reference angle, by definition, is going to be the positive acute angle between the terminal ray and the closest x-axis, not the closest y-axis, the closest x-axis. So your reference angle is now this right here. Is that the same as your angle theta? No, because theta is obtuse, right? So how could you find the reference angle if you know theta? Yeah, it's going to be 180 degrees minus whatever theta is. Sweet. Because you're stopping that much short of a half rotation, which is 180. Number 3, the third option. What's another quadrant in which theta could terminate? 3, yeah. So there's theta. It's between 180 and 270. But the reference angle is going to be that positive acute angle between the terminal ray and the closest x-axis, not the y-axis. So here is your theta ref. Is it the same as theta? No. But how can you find it? The reference angle will be what? Theta minus 180. Sweet. Now theta is bigger than 180 because we've gone past 180, right? And now we want to know by how many degrees have we gone past 180? So it's theta minus 180. 180 minus theta when you stop short of 180. Theta minus 180 when you've gone just past it. And then finally, the last quadrant in which theta can terminate is quadrant what? Pure. Good. All the way around here to quadrant 4. Theta now is going to be some angle between 270 and 360. But the reference angle is still the positive acute angle that's between the closest x-axis and the terminal ray, which is that dude right there. There's theta ref. And of course, theta ref now is not equal to theta, but we could still find it if we know what theta is, right? What is it? Look at the picture. What? Not theta minus 270. Theta minus 270 is going to give you this angle here, which would be the measure of the angle between the terminal ray and the y-axis, which is a very common mistake. Very good. We are stopping now short of a full rotation by how much? Whatever theta ref is. So it's 360 minus theta ref. You have to work off of your x-axis, which is 180 and 360. Don't work off of 90 and 270, because that would be an answer choice. All right, so when you draw a picture now of an angle, and I ask you to find the reference angle, the picture should tell you exactly what you need to do to find it, which is why I'm going to require you to draw the picture. Some people try to find reference angles without drawing pictures, and they always come up to me and they say, how do you know how to find the reference angle? How do you know whether to subtract it from 180 or 180 minus it or subtract it from 360? And I'm like, the picture tells you why. Have you drawn the picture? No, I'm kind of against diagrams, just categorically. And I'm like, whoa, you might want to change your beliefs, okay? Anyway, where else can an angle terminate? On the axes themselves. So those are special cases. Let's look at those. If you have an angle that terminates on, let's say, either the, I'll stay consistent with the blue here. If you have an angle that terminates on, let's say, the y-axis, whether it's that one or this one down here, is there such a small positive acute angle between the terminal ray and the x-axis? No. In this case, it would be 90 degrees, right? How far is it from there to the closest x-axis? It's 90 degrees. But is 90 degrees an acute angle? No. So there would be no reference angle. Okay, because 90 degrees is not acute. Okay? The other special case is when your angle terminates not on the y-axis, but on the x-axis. So it could terminate there. That would be an angle of 0. Or it could terminate over here. That would be an angle of 180. Well, what is the positive acute angle between the terminal ray and the x-axis? 0. Is 0 acute? It's less than 90, but it's not. It has to be strictly between 0 and 90. Yeah, you've collapsed it down to nothing. So we would say, again, there's no reference angle. There's no reference angle because it would be 0 degrees, which is, it basically collapses to nothing. The reason we're going to be looking at reference angles is because we're going to be looking at reference triangles. And reference triangles then are going to kind of be easier to work with because of your experience with Euclidean geometry. All right, so for the most part, if it terminates in an interior quadrant, if you draw the picture and you know where it lands in one positive rotation, which we just did up here, you'll be able then to figure out how far it is to the closest x-axis. And it always has to be a positive distance, right? That's why the reference angle is positive. And it always has to be acute because we're getting to the closest x-axis. All right, example 6. If beta is negative 265.363, draw beta in standard form. All right, so I'll just reuse this xy axis. And negative 265.363 is going to rotate in which direction? Clockwise. So here's negative 90. There's negative 180. I have to stop short of negative 270. So I'm going to be somewhere over here, and I'm going to call that beta. So beta terminates in quadrant what? 2, right? Quadrant 2. Part B, find the reference angle. Okie dokie. Well, the reference angle is going to be the positive acute angle between the terminal ray and the closest x-axis, which is over here at 180. So how am I going to find that? What's that? Well, you got to be careful. If I do the angle minus 180, the angle's negative. So if I go negative 265.363 minus 180, yeah, that's going to add them and give me an even more negative angle. So since we're looking for positive distances, you can just work with magnitudes of the angle, right? It's a little bit easier. So now that we know that the negative put us into quadrant 2, if we just work with the absolute value of the angle, that is just the positive 265.363, then I can subtract 180 and get what's left over. So there is that little extra that you have to do. Now, I do want to see this written down. This indicates your method. It shows me how you're finding your answer. All right, so now we'll just say positive 265.363. And this is the whole part of like thinking, what is reasonable? If you would have just subtracted 180, you're not going to get an acute angle, and it won't be positive either. Is 85.363 a positive acute angle? It is. So there is your reference angle. And what did I label it? B-ref. Yeah, B subscript REF. So that answers the question for part B. Part C, find the coterminal angle that is 47 positive rotations away from beta. All right, so this is a review. B subscript coterminal. I'm going to take my angle B, which is negative 265.363. And how do I find an angle that's 47 positive rotations away? Very good. It's going to be plus 47 times 360 or 360 times 47. So again, you show me your setup, so I know exactly how you're getting your answer. Negative 265.363. Now I want the negative angle there because it's the actual angle plus 47 times 360. If I wanted negative rotations, I would subtract. So it's 16654.637 degrees. It's coterminal with it, and it's 47 positive rotations away. And then it says convert all of them to DMS notation. I'm not going to do all of them because it's real easy now. But I have my angle right here, so all I have to do is hit second negative, which recalls the answer, and then go to my angle menu, right, which is second apps, and go down to number 4 and hit enter. And I'm permitting you to do that now. So you'd have 16,654 degrees, 38 minutes, and then 13.2 seconds. And then you could do that with the others if you want. I'm not going to do the other two because it's just as similar. So these angles right here are equivalent. They're one and the same, just a different way to measure it. Yeah. Make sure you turn in your calculator, and we'll see you tomorrow.